550. We're talking about the situation where Troy is building ramps and he's got a second ramp under construction. The second ramp extends from the deck on the back of the house to the backyard. The vertical rise from the yard to the deck is 18 inches. So I'm going to add that 18 inches, which is, by the way, 1.5 feet. If you didn't know that, let's just divide by 12. Hey Siri, what's 18 inches in feet?
1.5 feet.
And then to get that, hey Siri, what's 18 divided by 12? What's 18 divided by 12?
It's 1.5.
There you go. So to calculate, right, you should have everything labeled in the same units of measurement because that ratio of 1 to 12, the units are technically the same. No matter what they are, feet, inches, but you can't mix them. Now, draw a horizontal diagram, draw a diagram of the ramp, include the measurements from the vertical rise, time to bring in some highlight color, and the horizontal run of the ramp. Now calculate the length of the surface of the ramp. So the first thing I'm going to do is take 1 to 12, which is rise and run, slope, and I'm going to use the proportions, solving a proportion, to figure out what the length of our horizontal run of the ramp is. And then after I know that, then I'll use the Pythagorean theorem. A squared plus b squared equals c squared. So since 1.5 is like the 1 in the ratio 1/12, then I'm going to write 1.5 as the top of its own fraction. Now, x is in the run location, just like 12 is in the run. So we have 1.5 rise, that's feet, that's 18 inches, so everything's still staying the same. And we have x for run going on the bottom. Now, if I do some cross multiply, that is a cross product, that is multiplying both fractions by both denominators, ultimately what will happen is the 12 and the x will be reduced from their sides of their fractions and become 1 times x as a whole number, no fraction. And then on the other side, the x would be reduced, but 1.5 would be multiplied by 12 through that process. So now we need to figure out what 1.5 times 12 is. I think it's 18 feet. But let's just do the calculation here. Hey Siri, what's 1.5 times 12?
1.5 times 12 is 18.
Okay, so it's feet, and that little apostrophe, represents a foot measurement. Now, I can take these two numbers and I can put them into the Pythagorean theorem to figure out the length of the surface of the ramp, which will be that green highlighted line right there. So a squared would be 1.5 squared, and b squared would be 18 squared, and then it's going to equal the length of the ramp, which we don't know, so I'm going to use c, or maybe not that, use h, right? Whichever. So as long as we know that the result of the Pythagorean theorem is the diagonal, the hypotenuse of the triangle. So figuring out what squares are can be a challenge. Let's go to the yellow calculator for this one. And so I've got calculations from previous math problems. Don't delete any of this. Like I know students want to say menu 1.5 and they want to clear the entire screen. Don't do that. Control Z. We want to keep our math visible in case we forgot how to do a step. And we can go back up and figure out, oh yeah, that's right. I remember doing that step 4 lessons ago. Okay, so 1.5 squared plus 18 squared. 1.5 squared plus 18 squared. Enter. Is approximately 326, no, it's exactly 326.25. 326.25 equals c squared. If we want to figure out the c value, it's currently squared. That's what the theorem does. It is a square of this side. So we're going to need to square root to figure out what c is without the square on top of it. Square root is located here. It's yellow. So to get to it, you got to press Control and then press x squared. Now you could type everything all again. You could type 326.25 and you could get an answer. But the other thing that we can do is we can use this ANS down here, which is abbreviation for answer, and it's going to go take the recent answer and do some math with it. So the math that I want to be done to the most recent answer is I want it square rooted. Square root of that answer, I get 18.0624. 18.0624. That is the length of the ramp. So this is 18 on the horizontal run, but the length of the ramp is 18.0624. Okay, compare the two ramps. Are the triangles similar? And in order for us to compare the two ramps, all we have to do is compare the ratio of opposite to adjacent sides. So I already have this math on this page. I'm just going to write it right down. I have 1.5 over 18. I want to compare that, question mark time, to the information from the other side, 2.5 to 30. And we want to see if we have the same ratio, because if we do, then we can say the triangles are similar. Hey Siri, what's 1.5 divided by 18?
1.5 divided by 18 is approximately 0.08333.
Okay. Hey Siri, what's 2.5 divided by 30?
It's approximately 0.08333.
Okay, since they are the same decimal, that is, yes, the triangles are similar. Yes. Now it's because, I should say it this way, triangles are similar because, and we need to point back to a theorem that we used in the previous topic, and the theorem I want to recognize is SAS. We have a pair of sides that form a proportion, or a ratio, and we have a second pair of sides that form, well, I guess maybe it's more like this side to this side, and we have this side to this side, but it is the fact that they are equivalent ratios, and then they are based upon a 90-degree angle. So yes, because of SAS similarity. There's another one you could have said. You could have said hypotenuse leg similarity. But the point is, we have in this case no, it'll be leg angle. Whatever. We have two similar triangles. The ratio produces the same decimal. What does the ratio of the rise of the ramp to the run of the ramp represent? Slope? Because rise and run are both words that we've used to describe slope in the past as well. Slope is rise over run. It's the change in the vertical, so vertical, over or divided by the change in the horizontal. So horizontal. Okay? And that's consistent from any time you've talked about like non-geometry things like graphing, that between 2 points, there's a rise and a run. Compare and describe the angles of inclination. This is worth a pink highlight because on the previous page, page 549, we talked about incline, and incline is like how much change there is in the steepness of the ramp. So the angle of inclination is the angle above the horizontal. So this is horizontal and the ramp climbs. That angle is the angle of inclination. It's how much growth or like aiming up the ramp has. There is a word for if we go an angle down, that's declination or depression. But in this case, because we're talking about ground level and then measuring up to where the door's entryway is on the building, usually doors are not on ground level. They are up a little bit because of foundation, because of, flooding. We want to try to elevate the house above a crawl space. So there's reasons for this angle to be like aiming up with the ramp instead of down. Now, compare and describe both angles of inclination are congruent. They have to be congruent. The triangles are similar. In similar triangles, corresponding angles are congruent. That is visible on the screen, I believe. Okay, that is it for this video. I appreciate you watching it all the way through the end. I have nothing more in the moment to share with you, other than I do want to remind you that yes, we have talked about trig ratios, and we solve for unknown side lengths in triangles, and then we've applied trig ratios to solve real-world problems involving right triangles. So thank you for sticking around. We have some more to discuss. Page 551 is next, and I'll see you in the next episode.